140 billion up to about 220 billion, and that's just, additional cost to the power sector. When you translate that and move that through the economy, plus the increase to the price of electricity, and is also an increase to the price of natural gas, what you see is there's an impact to the economy from about 175 to about $275 billion. Again, this is present value over 25 years. Okay? So this is a more comprehensive assessment of the impacts of, the potential impacts of a suite of these regulations. One thing we do not do in this economic analysis, and makes it hard to compare to the analysis that EPA does, we do not include any of the potential benefits that EPA assigns to these regulations. So there's nothing here about benefits to health or environment. This is purely from the cost side. Just want to make that clear. And then in terms of, this is the last couple of slides, just in terms of, what are the environmental results. So this is just CO2 emissions. So we actually don't see very much changes in CO2 emissions because of these policies. Again, these policies are not targeting CO2 specifically. And it's a pretty flat trajectory because of this assumption we have about not being able to build new coal plants. But we do see changes in SO2 emissions. So this is a historical picture. This is our baseline. And then this is the impact of those regulations on SO2 emissions, and sort of a similar picture for NOx emissions. If you compare these to EPA's estimates, we actually have lower emission levels because we actually have a broader suite of regulations that we're including in the analysis. So again, it's a bit of a hard comparison to make. So summary, as I've indicated and shown that there's a range of cost estimates. So there is some potential to lower the costs through some innovation and optimization in emissions control and other compliance control technologies. And that, at EPRI, we're very much focused on pursuing those advanced technologies and trying to meet, the same level of environmental outcome, but at lower costs. And that is the end of the presentation.
Questions? Questions?
Bill.
What are the technologies in particular that you're thinking of?
Yeah, so let's see if I can work this up. Yeah, so I mean, in particular, for example, in the case of looking to get the SO2 reductions, okay, the high cost case essentially applies wet scrubbers across the board. And so what we did is we said, okay, based on the type of coal and based on where the units, controls that they had, we allowed some flexibility in those controls where some of them were using dry sorbent injection technologies. And then, for example, for the eastern bituminous coal, we applied lime spray dryers. So that's just, one example of, the comparing and contrasting of something that we consider a higher cost technology versus lower cost. On mercury, again, the higher cost had ACI plus a fabric filter sort of across the board. And then on the lower cost, we actually used an EPRI developed technology called Toxicon, which allows you to get very low mercury removals, but at a much lower cost. On the water side, on the 316B cooling regulation, the high cost essentially had closed cycle cooling across the board on every single plant, which we recognize now with some of the new information from EPA is sort of probably an extreme high cost case. And on the lower cost case, what we did based on some research that our water program did, where they mapped pretty much all the units across the country as to where they were that only those units that were on sort of sensitive water ecosystems, sort of on oceans, estuaries, tidal rivers, and so on, they would have closed cycle cooling, new closed cycle cooling units. And pretty much every other facility would only have a 10% of the cost of a closed cycle cooling to sort of represent that they'd have to do something from where they were, but not that full cost. So that's some examples. I forgot to mention that there's actually about a 25-page report on this analysis that you can get if you go to the EPRI website, put in PRISM 2 in a search, and you'll come up with the report, and that has a lot more detail on the different options that were included in the analysis. Yes?
Yeah, did you, you said in the overall economic cost to the GDP, you said you did include the benefits of health, et cetera.
Right.
What about new jobs being created, more steel being sold, those kind of things?
Well, so the level of aggregation of this model isn't going to capture that. I mean, we have a lot of detail on the power sector, and then on energy demand. Once we move up from that, we pretty much like like California or Texas, some of our independent regions that we have in the model, all of manufacturing output is represented by just one quantity. We don't break it down into many different subcategories. And I mean, sort of as an economist, you would say it's very difficult to track what happens to jobs, for example, or what happens to different sectors. So on the one hand, you are going to see increased investment, and we do see increased investment because of additional costs. So the power sector has an outlay, which then transfers that money to a different sector of the economy. So power sector goes down a little bit because of cost, but other sectors might go up a little bit. How does that all wash out in the economy? It's very difficult to track, and most economists will tell you that over the course of a decade or two, it sort of all washes out. However, what is the other sort of the impact is on energy prices. So here we're showing a bit of an increase in electricity prices, which, for those of you who've been following a lot of the media lately about low price of natural gas, where that's now seen as a boon to other manufacturing in the country, right? There's sort of this new term of onshoring. So I just read that one chemical company is dismantling a plant in Chile and moving that plant in Chile to Louisiana so that they can take advantage of the lower price of natural gas. So from an economic perspective, energy prices are going to have more of an impact on overall economic activity and GDP, and that's part of what we captured here.
Other questions?
Everybody's hungry.
Thank you
Okay,
very much.
all right, sure.
How about one additional hand for all the speakers this morning? And I assume lunch is going to be in the same place as yesterday. Okay, have a good lunch. Thank you. Somebody left their glasses here, glasses.